Right, so the locus of a point that the fixed distance from a focus is the same as that point to the directrix is our parabola. So going back to our mathematics work from that. So really what we're looking at, so we're saying that eccentricity there is 1. What we're looking at is what happens when the eccentricity, so the distance between the focus and a point, and that same point to the directrix, what happens when it's less than 1, and what happens when it's greater than 1. Okay, and we get those two different main types of conics that we're going to be looking at in this section of your course. So, an ellipse is defined as the locus of the point which moves so that the distance from the focus is less than the distance to the directrix. Okay, so we're saying that eccentricity, that ratio, is less than 1. Okay, so for a parabola, the eccentricity is 1, but when we have it less than 1, the distance between the focus and a point is less than that same point to the directrix, less than 1, we will form an ellipse. Okay, and that's what it looks like. Okay, so what it's saying is the distance SP is less than the distance PD. Okay, so for our parabola, the distance SP was equal to the distance PD. Okay, for our parabola, but when it's less, okay, we're going to have a closed loop, so to speak. Okay, and what we call formally our ellipse. Okay, so when we have these conics, we're going to establish that there are two foci and two directrices. Okay, so as that point P goes around, okay, the ratio of the distance from PS and the PD is always going to be equal in value, which is the value that's less than 1. Okay, that ratio, whatever it is, as long as it's less than 1, will follow that path that will always form an ellipse there. Okay, so conic is a lot of algebra. Okay, so it's really manipulating a lot of algebras thing to be able to derive our results. Okay, so what we're going to do first is we are going to derive the following equations for what we need to know about the ellipse. Okay, so what we're going to get to, we're going to find it, we're going to prove that formula. Okay, so that would be our general formula for an ellipse at the centre, at the origin. So, let's derive it. So, we're going to look at the proof. So, we know the distance, we're going to consider the point P at capital A here, alright, just to make things a bit easier for ourselves. And that's the point A which has value, coordinates, we're going to call it little a, 0, just to make maths a bit easier with our approach. So, the definition of the eccentricity, okay, so SA, the distance from here to here, that point, to the distance to the directrix, so AD, so a point on that vertical axis there, okay, is equal to that ratio eccentricity. Okay, so SA, we're establishing that this distance here is shorter than this distance here. Alright, and that forms the definition of our ellipse, where that ratio is less than 1. Alright, so what that means, S, so that's just a point D, alright, on the directrix that we're establishing. Alright, so SA is equal to E lots of AD. Alright. Now, that will also mean, because we've got a double foci, so two foci, so S prime A is going to be S prime D. Okay, so in other words, S prime A is going to be E A prime D. From there. Right, so from that, we're going back to our diagram. So SA, so this distance here, plus SA prime, which is the distance from here to here, because there's a symmetry that we're about to establish as well. Alright, so the distance from here to here is A, that must be the same from here to here, okay, because of the symmetry of an ellipse, like a circle with the centre at the origin. So, SA plus SA prime is going to be 2A. Okay, so that little bit there, here, plus that whole bit there, is going to be that plus that, isn't it? Okay, due to the symmetry, so we're going to have 2A. Right, so that's equation 1 we're going to deal with. Right, equation 2. SA prime, take away SA. Right, so we've already established from here the ratio for the eccentricity, and we've got an expression for SA and SA prime. Alright, so what I'm going to do is substitute those two values that I've already established into that formula there. So E A prime D, take away E AD. Right, both have a common factor of the eccentricity E. Right, so A prime D, which is that distance of the entire major axis length of 2A, plus that extra little bit there, and then we're taking away AD. So we're taking away that little bit there. So we're remaining with the distance at the end point of the ellipse on the axis there. Alright, so really, is E outside of 2A. AD, A prime D, take away AD, use 2A. Okay, and that's equation 2. Right, so we're going to write up a pair of equations. So 1 plus 2. And the reason why I'm adding them is because I'm going to eliminate this variable here. Alright, so I've already got that plus that, because that plus that will go to 0. So I've got 2 S A prime equals 2A plus 2A E. So about pen. Right, so 2A plus 2AE. Right, so we're going to factor the 2A out. Oh, so we're going to tidy it up. So 2 lots of SA prime is going to be 2A plus 2AE. Right, so we're factorising those 2's out, and we're going to cancel it with the 2 on the other side, and then we can take the common factor of A out on the right hand side. So SA prime is going to be A outside of 1 plus E. Alright, so equation 1 take away equation 2, so now I'm going to get the other variable, the subject. So if I do SA prime take away SA prime, it's going to get 0. So I'm going to have 2 lots of SA, which is going to be 2A take away E outside of 2A. Alright, and we'll do the same sort of approach. So I'm going to get 2A1 take away E after we factorise, and then we can cancel the 2's. So we're going to get a very similar expression with a minus sign between. Right, so what we're building into is that focus coordinate. Okay, so we're labelling that fixed point, S as the focus, and we now need to establish, so that we can finish the proof, that's the origin O, in relation to the focus. Okay, so the focus S, the distance OS, is going to be OA, so it's going to be that overall distance from here to here, take away that bit there. Alright, because I've already got an expression for SA. Or AS, SA, what do I call it? SA. Okay, so the distance OA we've labelled as A, the coordinate for the capital A. Take away SA. So there should be an A out the front. Right, tidy it up. Okay, so we get AE. And that's the value you're going to get for the focus. Okay, so therefore, S is going to have the coordinate plus or minus AE 0. So whatever the value for the eccentricity is, remember it's less than 1, right? Multiplied by the value A, which is the x-intercept when the ellipse is at the origin. Okay, now because E is less than 1, that's going to bring the focus inside the endpoint of the ellipse. Okay, and that's going to be the coordinate of the focus. So plus or minus AE, comma 0. So that's going to be positive, obviously. This is going to be negative AE 0 for the coordinates of the focus. Right, so now we need the directrix. So we need OD. Okay, we're really calling any general point Z on the directrix. Let's just change this variable to a Z, because I'm referencing the whole, no, scrap that. Let's call the overall directrix a Z, okay, so the general, so really find the X value where Z is, okay, instead of just relying just on that specific point in relation to where that point is set. Right, so it's going to be OA plus AD for the value, for the X value of Z where the directrix is. The directrix okay, so OZ is OA plus AD. Right, because we've already got an expression for AD. So E, so A, which was A, sorry, A. Now, AD. So AD times E is equal to SA, so let's call it equation 3. It's way back from the start. Okay, so I'm going to write an expression for AD in relation to those variables there. Okay, so SA over E. Okay, using 3. Right, so AE over E, because I'm going to get the common denominator for that expression here. And then SA, what we've established on the other side, SA is that. So when we expand that out, we're going to have AE take away AE, which is 0 plus A all over E. And that's going to be giving you the x value of the directrix. Alright, and because of the symmetry, there's going to be a directrix on the other side as well. With the equation of the value of the eccentricity and the value where it intercepts the x-axis, okay, and that will give you the coordinates of the focus and the equation of the directrices of your ellipse. Okay, we need those because we need to be able to now write down the formula. So, by definition, the SP, so we're going back to proving the locus of that point P as it moves, so that it matches the condition with the eccentricity. Okay, so SP is equal to E times PD. That's the definition from the start. Okay, so now we find the locus. Remember we found the locus of a circle or a parabola. Okay, we had to relate the distance equation. Alright, so to eliminate the square root, we square both sides using our distance formula. Okay, so what we're really doing. Alright, so we've got that focus, F, the point P, and the directrix at D. So we are showing that locus of the point P that follows. Sorry? Because remember we've got the distance formula, so the distance from here to here is equal to the eccentricity times the distance there, and we square both sides to remove the square root.
So you just relate the one down distance because there's not a square root there, it's just in the formula.
Yes, so I'm squaring it now, so we don't have to worry about a square root at all. Yep. Alright, so S has the coordinates AE, 0 for the focus on that side. Alright, so we're looking for the locus of the point P. We're going to call it XY. What's the coordinate of D in relation to what I've proved and what's in the diagram? A over E for the x value, because that's where it intersects the x-axis. And what's the y value? Just y, okay, because we relation, because it's perpendicular here. Alright, so it's relation to what I've got for the y value over there. Alright, so using your distance formula, so we're going to do x take away AE plus y take away 0 or squared for the distance PS using your distance formula. Now, E squared, okay, because I'm squaring the eccentricity as well. Alright, PD. So x take away A over E or squared plus our y take away y or squared. Right, so x squared take away 2aex plus a squared e squared plus y squared, so we're expanding out the left hand side. Must equal e squared minus 2a x over e and of course y plus y take away y is 0, so we can remove that part. Alright, so x squared take away 2aex plus a squared e squared plus y squared, e squared x squared minus 2aex plus a squared. Okay, now we've got negative 2aex, negative 2aex. So great, that helps. So, x squared plus y squared. I'm going to leave x's and y's on the left hand side. Move everything else, hang on, just look at the e squared, x squared. Take away e squared, x squared. Is going to be a squared, take away a squared, e squared. I don't know why we've been doing this. Right, so I'm just rearranging stuff, getting all my variables on the left and any constant terms on the right. Okay, so factorise the 1 minus h squared out of those two terms. Now what I'm going to do is I'm going to divide everything by a squared outside of 1 minus h squared. So are there any questions so far? Sort of somewhat following what's going on? Somewhat? Yeah, so it's really what we've done in mathematics in terms of showing the locus of a point that moves equidistant, etc., which is a bit more terms involved. I'm going to divide everything by what's on the right hand side. Okay, so that becomes x squared over a squared plus y squared over a squared 1 minus e squared is equal to 1. And we've almost got that formula on the next page of your notes. Okay, except for what's in the denominator of the y squared fraction. Okay, but we know that when x equals 0, y is plus minus b from your original diagram. Okay, so should go back and label it. So I've labelled this little a, so let's call this little b, and negative little b, right, for the intercepts on the y-axis. So we're just going to call it a variable there for your formula. Right, so your b squared over a squared, 1 minus e squared, is equal to 1. Right, because x's will go to 0. So I'm substituting that variable in. Okay, so b squared is equal to a squared, 1 minus e squared. So cross multiplying. And that's exactly what I've got in this denominator here. Okay, so that matches my formula. I can now put b squared there. Okay. Now continuing on here, right, so b squared is going to be a squared minus a squared e squared. Alright, so expand because I want to get the eccentricity of the subject, because that's what you need. Because that value for the eccentricity will give you all your focus, directricity, etc., etc. Okay, and a couple of other things in there. So e squared is going going to be a squared take away b squared on a squared. There's a couple of steps involved there. That's the end result. Okay, so get a squared e squared by itself, and then divide everything by a squared. Okay, and that's how you find your eccentricity. Okay, so whatever's in the formula for a squared and b squared, that will give you the value for your eccentricity. Alright, so therefore, x squared on a squared plus y squared on b squared is 1, and that's the formula for your ellipse. Right, you've taken enough of that in to know what's going on? Right. So, the Cartesian equation of the ellipse with the centre at the origin is given by that equation there. Okay, so gone through how it's been derived. So x squared on a squared plus y squared on b squared is equal to 1. Alright, so a's and b's are the intercepts of your axes for the ellipse. Okay, now, a couple of things you have to know. So, when the value for a is greater than the value for b, okay? So in other words, the value under the x squared on the denominator of x squared is bigger than the value underneath the y in the denominator of y squared. Okay, we have what's probably going to seem to you guys as what's the normal ellipse. Okay, so we've already established the coordinates of the focus. Okay, by setting it up there, we got the intercepts of the axes with the ellipse with a's and b's, and that's what you get from your formula, from what I've set. Okay, and the equation of your directricity a over e and negative a over e on your x-axis. Alright, that's the diagram that will occur. And there's your summary. Okay, so to find the eccentricity, there's your formula that you need to know. Okay, so the centre where the axis of symmetries cross. Okay, so because the axis of symmetry is the actual axis themselves. Right, so we're going to have them crossing at the origin. Okay, so the foci will lie on the major axis. Okay, so the major axis is going to be the horizontal because that's where the foci lie. Okay, and the minor axis is the axis that's going to be perpendicular to the major axis. Okay, with the lengths 2a and 2b, coordinates of the foci and the equation of directricity I have already talked about. I feel like I've lost you too. Do I need to stop for a moment? Are you sure? Okay, so when b is greater than a, so when the value underneath y is bigger than the value underneath x in your formula, okay, so when this number is bigger than that number, okay, you actually have a shift in your ellipse. Okay? So the following. So it's very similar in terms of the variables you've used. Okay, so you really just interchange your a's and b's, x's and y's. Okay, and then you get that following formula. Alright, so with a similar proof, I can show that. Therefore, the eccentricity is going to be b squared take away a squared all over b squared. Okay, same axis symmetry where the centre is. The foci lies on the major axis. Because the value for b is greater than a, the foci is going to lie on that vertical axis. Okay, so on the horizontal it was AE comma 0 and negative AE comma 0. So when the foci is on this axis, it's going to be 0 comma BE and 0 comma negative BE. Alright, that makes your directricities cross the y-axis at, for the other parabola it was plus or minus A over E. So for this one it's going to be plus or minus B over E. Okay, and that's all there. So the location of the foci, either horizontally or vertically for the ellipse, is dependent on which value of A or B is greater. Right, so typically you're going to have that one. typically, not always, right? But we need to know that what happens when we get that value which is greater, the other value which is greater than the original value. Right, question? No questions at all? You've taken that in wonderfully, have you?
What's E? What's eccentricity?
Eccentricity is the ratio of the distance from the focus to a point and the same point to the directrix. Okay, so you've got your ellipse. All right, so you've got S, P, and D. All right, so the ratio of the distance SP over PD is the eccentricity. Okay, when we worked on your parabola, that distance was the same. Okay, the distance SP on your parabola, okay, wherever. Okay, what it's saying for your parabola, those were two equidistant. Therefore, the eccentricity is 1. Alright, so what we're looking at this topic is what happens when the eccentricity is not 1. What sort of conics do you get formed with all that? Any other questions? Right, let's look at a couple of questions just to clear up that understanding. Alright, so let's find the equation of the locus of a point P. X, y, such a distance from the point S, okay, it's labelled as focus, to 0 is half the distance to the line from the line x equals 8. Okay, so this is our ellipse because the distance from the focus to that point is less than the distance from that point to the directrix. Okay, because we're told that's half the distance. Alright, so in other words, what it's saying is that SP over P to the directrix, D, the ratio of that is a half. Okay, so in other words, 2 SP is going to be PD. The two lots of that distance from the focus to the point on the ellipse is going to be equal to that same point to the directrix because the distance is half from there. Right, so we're going to find the distance, so we need to square those to remove the square root for our distance formula. So 4. Right. I shouldn't technically draw that because in theory we're showing it that. So we've got the point S at 2, 0. Got some point P, x, y, and it's half the distance to the line x equals 8. So I'm going to call that D because D is directrix. We know that the x value is 8 and the y value, well, we don't actually know. So we're going to make it in relation to what I've got in the diagram already. I'm going to call it y. So really, I'm just doing the same thing I did before. I just know what the eccentricity is now, and I don't have a lot of messy variables. I've got some more numbers to work with. Alright, so square 2, which is 4, SP, the distance, so x take away 2, all squared, plus y take away 0, all squared, using the distance formula. Alright, then PD, so x take away 8, all squared, plus y take away y, all squared. Okay, so this is what you should already be familiar with. Okay, so going to tidy it all up. Okay, so move all the variables on the left hand side, constant number on the right. Right, you both up to there. Right, so we need to get the right hand side equals 1, because that's that formula, x squared over a squared plus y squared over b squared is 1. Alright, so we need to make that 1. Alright, so divide by 48. How many 3's go into 48? Okay. So x squared on 16. How many 4's go into 48? 12. So y squared on 12 is 1. Okay, and that's the format of our ellipse.
That's not that bad.
It's just very new, isn't it? Very, very new. Find the equation of the locus. So that's the locus. Right? So, x squared over a squared plus y squared over b squared is equal to 1. That is your ellipse formula. So, does the focus lie on the major axis horizontally or the major axis which will be vertically? Why? Because the value under x is bigger. Alright, so a is bigger, so it's going to be your standard, I guess you could call it ellipse. Alright, you'll come across that one more often, but there will be times you come across when you have to flip.
Do we get them diagonally? Do we do with that?
Hey?
Do we get them diagonally?
For the ellipse, no. We'll just worry about this for now. Right, any questions on that? That's really what I've done with the proof. I've just created arbitrary variables. Okay, so now we've looked at numbers. Does that, what I've done previously, look a bit better, what I was trying to do? Okay, so I'm just trying to cover all bases, show you where it comes from, and help you with your algebra skills, because that's what we really need to get to be improved. Right, so it gets the graph of that. So x squared over 25 plus y squared over 4 is equal to 1. We need to now sketch it. So we need to know some bits and pieces. We need to know where the foci are. We need to know where the directrices are. Okay, so from that you should be able to tell me where the axis intercepts are. Okay, but most importantly, what do we need? We need the value for A, don't we? Because that will give us the value for the focus and the value for the directrix. Foci and directrices. Right, so do you remember the relation with the E's and A's and B's?
A squared equals A squared take away B squared over A squared?
Very good. Right, E squared. A squared take away B squared. Now there is a formula B squared take away A squared on B squared. Right, so you've got to be careful which one you use. And here, because A is greater than B, that's why I'm using this formula. Okay, if B was greater than A, it would be E squared equals B squared take away A squared over B squared. Right, so equal 25 take away 4 on 25. Yep.
Not squared.
Well, that's already squared in my formula, isn't it? Yep. So 21 on 25, so E is going to be the square root of 21 on 5. That's less than 1, isn't it? Yeah, because the square root of 25 is 5, so the square root of 21 must be less than 5. Number less than 5 over 5 must be less than 1. So those are the sort of things you need to check with your formula. Make sure you're consistent with what we're working with. Alright, so we found this value for C. So foci. What was the general form of the parabola of the foci? Plus or minus AE, comma 0. Remember, E is less than 1, so if A is the value where it intercepts the x-axis and the focus is inside the ellipse, okay, that must be the formula we need. So at plus or minus, what's the value for A? Just 5, okay, because A squared 25. So A is 5. Alright, so plus or minus 5 times root 21 on 5, comma 0. Okay, so in other words, at plus or minus root 21, 0. That's where your foci lies. Alright. What was the general format of the directrices? Well, there's a difference. So if you are dividing by a number that's less than 1, means your answer will be greater than the value for A. Which makes sense because the directrix is outside the ellipse. Okay? So plus or minus 5 over the square root of 21 on 5. Alright, cross multiply. You're multiplying by a fraction. You're dividing by a fraction, you multiply by the reciprocal, so plus or minus 25 on square root of 21. Okay, so we established that the square root of 21 is less than 5. The 25 divided by a number less than 5 is still going to be greater than 5, okay, which makes sense with the format of everything there. Right, I'm just going to do a rough sketch so that we get the idea. Of course, when you're doing this in your assessments, etc., it need to be done a bit better than what I'm doing here. Okay, no imaginary numbers involved in this topic. Okay, so don't get confused with your Argand diagrams and sketching conics. So we know that the centre was at the centre's at the origin. Okay, the value for A was 5 and the value for B is 4. B squared is 4, therefore the value for B is 2. Alright, poorly drawn. Fantastic. Alright, 2, negative 2, 5. Alright, I'm just getting you understanding where everything is. I don't care how neat it is right now. Okay, until we're good at them, then I'll be caring more how neat it is. Okay, so the foci, there's 2 of them, equidistant from the centre. Okay, and the coordinate is plus or minus root 21. So root 21 on the positive side, negative root 21 on the other side. Okay, and we'll just need to make this bigger. Okay, there's your directrix for that side and your directrix for this side. So x equals 25 on root 21. You may be asked to rationalise the denominator, okay, but right now we're not worried about that. And x is negative 25 on root 21. We're still hanging in there. Are we still hanging in there? Yep. Okay, I've sort of lied. Sort of, but not fully. What is the locus of the modulus of z plus 2 plus the modulus of z take away 2 equals 8? I've sort of lied, sorry.
I was comfortable.
Okay. Yeah. So the locus of the modulus of z take away z1 and z plus r take away z2, when you add them together, going to be equal to 2a, which will be in ellipse, with the foci at z1 and z2 and the major axis length of 2a. Alright, so where's the focus? So plus or minus 2, okay, on the x-axis, and we know that 2a is 8, 8 is 4, right, so we need to write down the Cartesian equation of z. So we're going to have x squared on a squared plus y squared on b squared is 1. Now, I did say there were no complex numbers involved, so we're not actually doing any calculation of complex numbers. We're just recognising that forms an ellipse, and we're getting the main bits information, and then we can essentially ignore it. Okay, so what do I need, though, to finish off that Cartesian equation? Pardon? E? Yep, to get what? Okay, so I've got A already. Yep, so x squared on 16 plus y squared on b squared is 1. So I need the value for b. To get the value for b, I need the value for e. So how am I going to get that value of e?
E squared equals a squared take.
Geez, one equation, two unknown variables. Don't really want that. You're going to have a good talk with the other two students today, aren't you? What do I know already in the whole question? What can I do with that?
E equals 2a times e equals 2.
That's our general form of the foci.
So we go e squared.
E is a half.
So AE is equal to 2. So 4E is 2. E is a half. Right, so now I've got the E. I know what A is. I can now much more straightforwardly find value for B. So E squared equals... Your turn. Okay. Yes, sorry. I mean, now I want to know the value for B. So we established the quarter, so now I want to know the value for B. Remember that formula? Alright. Formula sheet will be very handy because there'll be quite a few of these formulas coming. Alright, so a quarter is equal to a squared, 16, take away b squared on 16. Over 4, so 4 is equal to 16, take away b squared. B squared is going to be 12. And that's all I need to do, okay? Because I just need the general formula, Cartesian form. I don't need to do square root. Therefore, x squared over 16 plus y squared over 12 is equal to 1. Alright, that's probably be a good stopping point.